children, welcome back to my channel. You all know that I am passionate in teaching maths in a very simple and easy to understand method. Today's topic is Thales theorem. Today I am here with 5 hot questions based on Thales theorem. Let's begin with. Now the question is, find the value of x if DE is parallel to AB in triangle ABC. We have DE is parallel to AB, so we need to apply Thales theorem. Thales theorem states that if a line is drawn parallel to one side of the triangle to intersect the other two sides in distinct points, then the other two sides are divided in the same ratio. Hence we have CD by DA is equal to CE by EB. By substituting the values, 4 by x minus 4 is equal to x minus 3 divided by 3x minus 19. By cross multiplying, we get 4 into 3x minus 19 is equal to x minus 4 into x minus 3. 12x minus 76 is equal to x square minus 7x plus 12. By simplifying it, we get x square minus 19x plus 88 is equal to 0. Splitting the middle term, x square minus 11x minus 8x plus 88 is equal to 0. Take x as common, x into x minus 11 minus 8 as common, minus 8 into x minus 11 is equal to 0. X minus 8 into x minus 11 is equal to 0. Hence, the value of x is 8 or 11. This is a very interesting question. Prove that the bisector of an angle of a triangle divides the opposite side in the ratio of the sides containing the angle. Let me repeat the question. Bisector of an angle of the triangle. In triangle PQR, PS is the angle bisector. It divides the opposite side. Opposite side is QR. In the ratio of the sides containing that angle PQ and PR. Let me repeat. What is given is in triangle PQR, angle 1 is equal to angle 2. And we need to prove QS by SR is equal to PQ by PR. Let us draw RT parallel to SP and extend QP till T. From the given figure, we have PS is parallel to RT. Hence, angle 2 is equal to angle 3. They are alternate angles. Angle 2 is equal to angle 4. They are corresponding angles. And they have given angle 1 is equal to angle 2. From these three equations, we get angle 3 is equal to angle 4. In triangle PRT, if angle 3 is equal to angle 4, it becomes an isosceles triangle and angle 3 and 4 are base angles. Hence PT is equal to PR. In triangle QRT, SP is parallel to RT. We can apply basic proportionality theorem. Basic proportionality theorem states that if a line is drawn parallel to one side of the triangle to intersect the other two sides in two distinct points, then the other two sides are divided in the same ratio. QS by SR is equal to QP by PT. And we know that PT is equal to PR, we have proved. Hence, QS by SR is equal to PQ by PR, hence proved. This is very exciting question. If a line through one vertex of a triangle divides the opposite side in the ratio of the other two sides, then the line bisects the angle at the vertex. That is, in triangle ABC, if BD by DC is equal to BA by AC, then we need to prove that angle CAD is equal to angle BAD. Construction. Let us draw CE parallel to DA and let BA be extended till D. In triangle BCE, AD is parallel to EC. Hence, we can apply basic proportionality theorem. The basic proportionality theorem states that if a line is drawn parallel to one side of the triangle to meet the other two sides in two distinct points, the other two sides are divided in the same ratio. Hence, we have BD by DC is equal to BA by AE. But BD by DC is equal to AB by AC is given. This implies that AC and AE are equal. Hence, when AC and AE are equal, triangle ACE becomes an isosceles triangle. And angle ACE is equal to angle AEC. As AD is parallel to EC, which is constructed, we have angle BAD is equal to angle AEC. They are corresponding angles. Angle CAD is equal to angle ACE, alternate angles. From these 3 equations, we get angle CAD is equal to angle BAD. Hence, proved. Here we have one more interesting question. The side BC of a triangle ABC is bisected at D. O is any point on AD. BO and CO produced to meet AC and AB at E and F respectively. AD is produced to X so that D is the midpoint of OX. Prove that AO is to AX is equal to AF is to AB and FE parallel to BC. Let us check the question once again. In triangle ABC, the side BC is bisected by D. Hence, D is the midpoint of BC. And he has also given that BO and CO are extended till E and F respectively. And AD is produced to X such that D is the midpoint of OX. And we need to prove AO by AX is equal to AF is to AB. And FE is parallel to BC. This is what we need to prove. Let us join BX and CX. Since D is the midpoint of BC and OX, OBXC is a parallelogram. In parallelogram, the diagonals bisect each other. Hence, OBXC is a parallelogram. In parallelogram, opposite sides are parallel to each other. Hence, BX is parallel to OC. BX is also parallel to FC because CO is extended till F. And BX is also parallel to FO. So when we take triangle ABX, BX is parallel to FO. So here we have the basic proportionality theorem again. It states that if a line is drawn parallel to one side of the triangle to intersect the other two sides in two distinct points, the other two sides are divided in the same ratio. Hence we have AO by OX is equal to AF by FB. Similarly, in XC is parallel to BO, opposite sides of the parallelogram. XC is also parallel to BE as BO is extended till E. XC is parallel to OE. So in triangle AXC, since OE is parallel to XC, basic proportionality theorem can be applied. The statement of basic proportionality theorem is if a line is drawn parallel to one side of the triangle to intersect the other two sides in two distinct points, the other two sides are divided in the same ratio. Hence in triangle ACX, COE is parallel to CX, hence AO by OX is equal to AE by EC. From equation 1 and 2 we get AF by FB is equal to AE by EC. The RHS and RHS are equal since LHS and LHS are already equal. From this we get FA is parallel to BC, converse of BPT. From equation 1, we have AO by OX is equal to AF by FB. We can rewrite it as OX by AO is equal to FB by AF. By adding 1 on each sides, we get OX plus AO by AO is equal to FB plus AF by AF, which is equal to AX by AO is equal to AB by AF. It can be rewritten as AO by AX is equal to AF by AB. Hence, AO is to AX is equal to AF is to AB. It is proved. This is an interesting question here. The external bisector of an angle of a triangle divides the opposite side externally in the ratio of the sides containing the triangle. Let me repeat. The external bisector of a triangle. In triangle ABC, AD is the external bisector. Angle 1 is equal to angle 2. And we need to prove that BD by CD is equal to AB by AC. Let us draw CE parallel to DA. Let us draw CE parallel to DA. From the figure, see when CE is parallel to DA, angle 3 is equal to angle 1. They are alternate angles. Angle 4 is equal to angle 2. They are corresponding angles. And angle 1 is equal to angle 2 they have given. From these three equations we get angle 3 is equal to angle 4. In triangle AEC, when angle 3 and 4 are equal, they become the base angles and triangle AEC becomes a isosceles triangle. Hence, AE is equal to AC. In triangle ABD, we know that BD by CD is equal to BA by AE by corollary of basic proportionality theorem. We know that AE is equal to AC, proved. Hence, BD by CD is equal to AB by AC, hence proved. Hope today's class was very interesting. I thank all my viewers who have subscribed to my channel. If you haven't, please do like, share and subscribe to my channels to your friends and relatives. Stay tuned for next videos.